Hi everyone. So today I talk about free body diagram, and you need free body diagram basically whenever you have a question where you have 2, 3 forces on one object, and then you're asked about either acceleration, the mass of the object, or any of the forces that are exerted on the object. Okay, so in those scenarios we use free body diagrams in order for us to solve the problem easier. There is a recipe you need to follow for free body diagram. And if you follow that recipe step by step, you never go wrong with your drawing and also with the answering the question. The first thing is draw a dot instead of the object. If it's a box, if it's a child, if it's a guy over somewhere, whatever it is, draw a dot instead of the object that's in the question. Secondly, because we live on Earth, no matter where you are, if you're in the air, if you're on the ground, if you're on this table sitting, or whatever, wherever you are, we have weight due to our mass because of Earth. So, no matter if we are in the air or not, we draw weight for the object. Okay? And we know weight is a downward force towards Earth, and it's mg, mass times acceleration due to Earth. This is weight. Thirdly, draw all and only, please don't forget this, only the forces that are in direct contact with the object. Okay? Please, no matter how tempted you are to add more forces to the free body diagram, please refrain from doing so. Draw all and only forces that are in direct contact with your object. Okay? Once you're done with this stage, then you are done with drawing free body diagram. Then what you need to do afterwards is basically writing Newton's second law. F net equals m times a. Okay? Now that you have your free body diagram set up already, then it's easy to figure out what F net is, just because you look at the diagram and just write whatever the F net looks like, mass times acceleration, and you go from there. Okay? So let's just practice a little bit on this free body diagrams and, try to make some sense out of it. If I tell you there is a box here with mass of 10 kilograms, okay? Now, I push this, so this is the force from my hand. I push this by 50 newtons, and this pushing force gives rise to the fact that the box that's 10 kilograms will accelerate by 2 meters per second squared. Okay? What is the frictional force that's because of the floor that the box is on in the question that it gives rise to this motion? Okay, so I have a box of 10 kilograms. It goes by 2 meters per second squared because of my force, because of my hand, force due to my hand, that is 50 newtons. Now I'm solving for the frictional force. First comes first. Free body diagram tells me first draw a dot instead of this block. Now draw the weight of mg. I'm done with the second part. Thirdly, draw all and only forces that are in direct contact with your object. If you isolate, like if you take a look at this, if you zoom into this object, there is my hand pushing it and also the floor. Floor gives frictional force in the opposite direction to the motion, because when I'm pushing it this way, this box moves that way. So frictional force is the opposite direction. Also, because of the floor, there is a support force, there is a normal force. And because I know this is not jumping up and down and it's staying still, I know the normal force is canceled by the weight, because these two has to cancel out so that this is motionless along this axis, along the y direction. So this is normal force, and this is my hand that's pushing it. Okay, so this is the free body diagram, and please be careful. Frictional force is always small. It should be smaller than any other force, because eventually your hand that's pulling it this way is basically gives rise to the motion. So frictional force is always smaller, right? Now write out F net equals m times a. What is F net? Force of my hand minus, see, this is opposite to this force, the direction. If they are opposite, I said in the other video, if forces are in the opposite direction, they get subtracted, right? This is going to be canceling out a little bit of this force of hand, right? Frictional force equals mass times acceleration of 2 meters per second squared. What is the force of my hand? 50 newtons, right? 50 minus F of friction gives me 20. Therefore, frictional force has to be 20 minus 50, which is minus 30. That's negative frictional force. So therefore, frictional force is 30 newtons. Okay? So this is basically how you do free body, how you solve problems doing free body diagram. As you can see, they're like force because of my hand, and then there is floor, which exerts some frictional force on it. So whenever you have 2 or 3 forces acting on one object, you better draw the free body diagram, because that really helps you understand the whole motion, right? So these two, you know, they cancel out just because it's not jumping up and down. And please be careful and remember this, that action along the x direction is separate from action along the y direction. See, here along the y direction, these two cancel out, and that's why it's not jumping up and down on the floor. It just doesn't go through the floor. It's not, you know, jumping off of the floor or anything. And this y-axis has to be treated separately from the action along from the motion along the x direction, which I actually wrote the formula for, as you can see here. So F net equals m times a is for all the forces that are exerted along the x-axis, because I know there is no motion along the y, right? Okay, so this is a wrap up for free body diagram problems. Make sure you study them. It's really, really just, you know, following the recipe and making sure you are basically following the recipe. That's pretty much it. I wish you all good luck and study hard. Bye-bye.